Okay, for the MATLAB demo about exponential decaying signal, we already opened the MATLAB editor here, and first thing we need to do is to define time domain signal. And for that, let me first define real number a as 1.5, that is positive number, and time interval, let's define time interval between 0 and 5 seconds, between with 0.1 second increments. Okay, then lowercase xt time domain signal is exp in parentheses minus a times t. So we obtain the time domain signal. Now let's plot this signal t xt. Okay, here is the plot of time domain signal. As you see, it's 1 at time 0. It goes to 0 as time increases. Okay, next we need to define the terms in frequency domain. For that, first thing I need to do is define the frequency increments. So the frequency interval we consider is between minus pi and pi, and the whole 2 pi interval, I divide this by 128 points, and let me define the increments as the omega, that is 2 pi divided by 127. Okay, and I define the omega term, omega, from minus pi with the omega increments up to pi. So on the left column you see a workspace here. The x omega is the vector by 1 by 128. So let me pull up the equation of x omega. From the previous slide we remember that x of omega is 1 over a plus I. Here the complex number j is denoted by I in MATLAB, I times omega. And of course I need to put point symbol here, and that is my uh, Fourier transform x of omega. And notice that that is also 1 point, that is also the vector with size 1 by 128. So let's open a new figure environment, and I will plot the magnitude, first magnitude of the x omega, that is ABS, absolute value, x omega, and that is this plot. Okay, that is the magnitude spectrum of the defined exponential signal. So if we make grids on this plot, we get this figure. Okay, as you notice here, at omega 0, it's as omega increases, its value decreases. So it's a kind of behavior of a low pass filter that gets that magnitude spectrum of the low pass filters gets smaller beyond a cutoff frequency. Okay. Next, I wanna plot the uh, phase spectrum of x omega. For this, it's sufficient to just write plot omega and angle of x omega. And I wanna put this in the new figure here. Okay. Now this is the uh, okay, the phase spectrum of exponentially decaying signal.